All right, let's do these together. Let's see if this will like me enough to work with it. All right, so we just did that introduction page where we looked for the pattern, and we're looking for the nth root of a number, and we're also saying the following. If the nth root of a number, a, is a real number, and m is an integer. So we're not doing fractions and fractions. Did everyone hear me? It's just single fractions right now. Could you do fractions and fractions? Yes, but we're not going there right now. This is not your life yet, okay? But if you had this, what did we discover? If I have anything raised, a to 1 over n, what do we do? What do we do to a? You take the root of it, not square root, the nth root of the value, right? You use the index of whatever that is. And that's why we practice already taking the cubic roots, square roots, fourth roots, fifth roots, all of that before our last test, because we're going to be applying it now with fractions. Now, what was the other thing that we discovered when we were doing this? All right, if I have a fraction and the number is not 1 on top, what do we do? Take the nth root of a, but then raise it to what? Yeah, so you take it to the nth power. Or you could take the nth root of a raised to the m power. Those will get you exactly the same answer. Now, I will tell you right now, this method is great if you have a calculator. And if I was just to say, hey, show the work, wonderful. Guess what, though? Your whole homework tonight is supposed to be done without a calculator. So this normally ends up being the best route. So use this one when there is no what? Calculator. Now, I just want to emphasize, though, do they get the same thing? And I've seen it on standardized tests where they'll be like, are these equivalents? And all they're doing is just rewriting a fractional exponent in those two methods. They'll be like, does this mean the same thing? And you'll go, yeah. So don't be surprised if you see fractional exponents show up on like your SAT, your PSAT. It's a big thing. Okay, especially on ACT, they do like 1 or 2. Like they don't spend tons of time on it, but these are stuff that you have. Yes?
Do we ever get those practice?
I'm sure they'll give them to you again closer to the date, but yeah. All right, because that, you know, is coming up in lovely October. Okay, let's see if we can do these and make our lives really, really easy. Because again, we're going to do this without calculator. Stuff that I'll show you some things that I noticed on people's tests that will affect how you do on these problems. And it was just like one problem that people just consistently, I'd probably say about a third of you missed again, that you should have done. Okay, but we'll get there in that moment. Okay, now guys, if I ask you to simplify these, now also we have these fractional exponents. What would you do first for this problem? Don't give me an answer because you know darn well you have to show work. This is me we're talking about here. Leah, what would we do? Should I rewrite that? Can we rewrite it in a language we understand? What are we going to rewrite that as? The cubic root of, all right, which is what number? 4. Now, again, what if you're not really good at this? Remember, you're just looking for that number that is a perfect cube. But when you work with it, you know, if you have to use it with the prime factorization stuff to a point, go for it. No one's going to stop you. But hopefully that's one that you recognize now. It's just going to be 4. Now, looking at this one, there's literally 2 ways to do this one. I'm going to show you one, then I'm going to show you the other one. I'll tell you right now, notes only shows 1. Now, when you're looking at this, you have 7 to the 1/2 times 7 to the 1/2. How would you rewrite this? Alex, what you got? All right. Not bad idea. Where did the 49 come from? Okay, but you can't do that when you have exponents like that. So what's the better way? I'm going to get the square root of 49, But what do I have to rewrite first? That becomes the square root of 7 times what? Square root of 7. Then, hello, if it's already in simplest form, you still have to multiply the numbers out front together and the numbers underneath together. So now I'm going to agree with Alex that I got my 49. And then what's the square root of 49? 7. Now, here's the other way you could have done this when you got it right. Have I thrown out any of your exponent rules? No. Guys, here's the thing. What do you do if you have the same base? What do you do with your exponents? So 7 to the 1/2 plus 1/2. Guys, what's 1/2 plus 1/2? 2 halves, which is what number? 7 to the first power is? The exponent rules didn't fly out the window just because it was a fraction. So that means you have to be good with common denominators and all that good stuff.
Sure.
Yes, you do. But for most of you, I would say this first route was probably better. Would you agree? But here's the thing. You can't leave it square root of 7 times square root of 7. You actually have to multiply. Okay? If they're the same root, you got to multiply. All right. Let's look at the next one. Now, can I add the exponents this time? No. So what are we going to do? Are we going to rewrite them?
Yes.
Yeah. So we're going to do the cubic root of 5 times the cubic root of 25. Now, again, I had you guys leave problems just like that and thought you're in simplest form. People, if we can do an operation, do we have to do it?
Yes.
So, what do I have to do here? The 5 and the what? The 25.
Okay.
So I get the cubic root of 125. All right. What's the cubic root of 125? People, don't forget to multiply. Are you with me on this? Well, let me give you a sidebar what I'm talking about. If I had something, let's go sidebar this direction. If I had something like this, x times the square root of 2x times y times the square root of 3x, we should know how to multiply those still? What do we get? We get xy times the square root of what? 6x squared. Now I need to do what? Simplify. Now, this is just what we did, right? This is just what we came off of doing. But I have to be able to take that square root of that x. So that becomes xy times x times the square root of 6. That's x squared y root what? 6. People, multiply if they have the same root, right? If we're having the same deal. The rules don't change just because I'm throwing fractional exponents on x.
Where did you put the absolute value on?
No, because it had it without it first. So its assumption has been made it's positive. Oh, that was a great question to ask. I was kind of hoping someone would ask it. You did, so good job. All right. Now, here's where things are good. You need to be able to convert forms so you can change, because sometimes, believe it or not, it's better to square and then take the cubic root and then square something. Sometimes it's better to do it the other way around, because the two different ways I showed you. You need to be able to get really good at writing it both ways. Again, number one reason I'm going to tell you this, besides you need to do it for a math class and for a grade, is for standardized tests. Okay? Also, when you get to higher level problems that you have not gotten to solving yet, you'll have fractional exponents that you got to get rid of. So we need to be able to be really comfortable converting things so we can work with it. Now, this first one says, if it's an exponential form, I'm going to radical form. So this would be like 5th root, 6th root, cube root, whatever. So I have to have the square root symbol on this. Okay? So, on the first one, what would you guys do first? How would you write this one? All right. It's a 7? No?
Yeah.
What do we got?
X is 7.
So this is the 7th root. So you said, I'm taking the 7th root of x, and then what are we doing? And then you're squaring it. Okay. Awesome. Talk to me. Could I do anything else with that if I really wanted to? I would accept that as an answer, but there's a different one you could do. or what?
Oh, you could square. You could do extra.
What could I do first? Square and then do what? Yeah, so I can still do the seventh root, but I could square the x first. Why are those equal? So here's the y moment. Don't write it down, just watch, because I want to make sure you understand the why. Here's the why. If I'm changing that so it's the seventh root of x being squared, isn't that the same thing as seventh root of x times the seventh root of x? And if I multiply together because they're the same root, I get x times x, which is just what? Do you see how it's the same thing? So if you see either one of those, the or version, they mean the same thing. Everyone keep hearing me. I think for most people, this one is still the best route because a lot of times it helps numbers become nicer when you have a physical number in there instead of a variable. A variable doesn't really make that much of a difference. No. Okay. This one, please. For the love of mathematics, don't be stupid. Does anyone see something different on this one? Oh, you mean there's a negative here?
Oh, that.
Because can we have negative exponents?
No.
What do negative exponents tell you to do?
Switch them.
Switch them in a what? A fraction. So negative exponent says, oh, this just turned into a fraction. Star that, make a smiley face, firework it, say Gregerson is going to ask a question like this again. But the fact is, negative exponents scream at you, move location, right? So what's the very first thing we're going to do? We're going to change that to 1 over x to what? X to the 2/5. Because the moment it changes location in a fraction, it becomes what? Positive. Then just do what you've been doing. Then just do what we've been doing here. So we get 1 over what? Oh, I've had 2 people answering. Should I be able to know how to write this based off it? Now, the 1 stays alone. What does this tell me to do? The 5th root of x, and then do what to it? Squared, or rewrite it as, now, again, if that's what you wrote, are you getting full credit from me right now?
Yep.
Yes. Or, can you rewrite it as the 5th root of x what? Do I care which one? If you don't like parentheses, which one should you use? The right one. If you don't mind parentheses, the left one. I kind of like the one on the right because there's no parentheses. Would you agree? Okay. Let's look at another one. Oh. What do I need to notice here?
It's negative.
Negative. All right. So what's the first thing you're going to do?
Put it over 1.
Put it over 1 and then do what?
Flip it.
S. So we go 1 over x to the positive 3/4. Now this is when it's really up to you. Which method do you want to do? Guys, which one do you like better of the 2 over here?
The first one.
The first one or the second one? Uh-huh. That's what I thought. Mixed for cutes. Great. Okay. Great. I have to do it both ways now. Good for me. All right. But guys, pick the method that works best for you. For some of you, you're going to think in your head, I got to do what to x? Cube it. For some of you, you're going to I'm going to cube the x and then take the what? The 4th root of it. Great. Some of you are not going to think that way. Some of you are going to think, hey, I'm going to do the denominator part of that fractional exponent first. I'm going to do the 4th root of x, but do what to it? Cube it. Is it going to get the same thing? Yes. Yes, sir.
When we give an answer, should we irrationalize the denominator? Rationalize it?
No, you do not have to right now. Right now, I'm just asking you to convert forms. I'm not asking you to simplify. You are correct. Simplifying would have to come into play otherwise. But right now, we're just learning to switch forms, which is going to be really huge when we're solving exponential logarithmic equations. So don't worry, that's a way away. Don't worry about it, guys. Sorry, big words shouldn't have come out yet. All right. doesn't matter which way you do it. You can do whatever first. Okay, quick clarification. Someone goes, do I cube it, then fourth root it, or do I take the fourth root and then cube it? Guess what? It doesn't which. You learn to get to the point when there's numbers there, you're like, okay, which one's just easier to do first? Which gives me small numbers or easy to work with numbers? All right, what's the problem with D? That was very dramatic. Yes, it's a decimal. Yes, very good. All right, okay, you've got to be good at working with decimals. You've got to be good at working with fractions and decimals. Now, guys, this isn't hard to do. But if you see a decimal, it's really a fraction. Okay? So, would you agree with me? This is the same thing as saying 2 to the 5 what? Tenths. Because 0.5 is 5 in the tenth spot, right? 5 tenths. All right, let's keep working with this a little bit. Should we be able to simplify that to x to the 2 to the 1 what? Half. Now, guys, I never took the time to practice this with you, converting mixed numbers to improper fractions. How do we change I gotta say this right, mixed numbers to improper fractions? Sam, what do we do?
Oh, so you just multiply by the bottom and then add to the top?
Yes. 2 times 2 is what?
Big
Plus
brain.
1. So it'd be x is raised to the 5 what? X. Okay, now, this was actually I'm very impressed. That was perfectly heard from the back. All right, guys. When you're changing mixed numbers in improper fractions, you multiply the denominator with the number out front. So 2 times 2, which is 4. Add it to the number on top, and that number goes on top. So 5 halves. Now, can we do the rules that we know about rational exponents? Yes. So when we're working with this one, again, you choose which way you want to do this one. Because we take the square root of x and raise it to what power? The 5th power. Or, what could you do? Square root of what? Oh, wait. Can you simplify that?
Probably.
That's a what? Yeah, we can simplify this. Guys, we know how to simplify. Now, if I'm just asking you to change forms, I'm not asking you to simplify. Would I be okay with this? But if you notice that you could simplify, am I really going to scream at you for being such a great student? No. But, you guys agree with me? That's x, square root of x to the 4th times the square root of x. What's the square root of x to the 4th? X squared times root what? Does anyone notice anything there? This one, I'm happy with this one. I'm happy with this one. And I'm happy with the last one. But does anyone see any pattern there that would help us out? This is a really high thinking problem. If you actually catch this, I'm going to go bring the Patterson that I have the smartest class.
I got it.
What is it?
Improper fraction.
Okay, the improper fraction. Where did the improper fraction come in? What do we got? Oh, I got x squared times x to the what? Okay, guys, this is so not on the notes, but I'm so doing this because it's so good. Oh, I can't help it. You guys are so going there. You get anything?
No, did I?
Yeah, you're thinking right. Both of you are thinking right. If I have x to the 2, did we have here x to the 2 and 1 half power, correct? Isn't that the same thing as going x squared times x to the 1 half power? So do I have to do anything with the x squared? Square root of. If you know your exponent rules inside and out, could you use those to your advantage? Absolutely. Do I expect you to do that on this lesson? And the answer is absolutely not. You're totally fine with the first two. In fact, I'm just going to highlight those because that's where I need you to go right now. We just need to learn. Why is this not? Oh, seriously, is this going to do this now to me? Yep, it's not going to let me do anything. We'll just circle those. Those are the two I really want. Are you guys with me? But if you could go to the other one, wow. I'm there. Okay. All right. I'm very proud of you. All right, are you feeling pretty good? Yeah. Totally good. Yeah. Go and just get on that one. Grab yours. Yes. Yes. All right, guys, let's see if we can get to where we need to go on this next one. Okay, let's see if my stuff is going to get here. Example. Woo-hoo, got to get to where we are. Okay, now, we got to go the other way, and I think the other way you guys are going to really like because it's pretty simple. Okay, can we change it now to a fraction? Oh, I'm sorry. Was that me who did that to you? Yeah. Oh, I'm sorry. What? Jackson, you liar! You reached just fine. Ah, you did
Ben,
just
why did
fine.
you get up, bro? Ben, why did you get up, bro?
Oh, dear. All right, back to the problem. Guys,
Chivalry is dead.
could we please? Thank you for doing that, by the way. I appreciate it. All right. Can we finish this, please? So you can have time to do homework? Okay. All right, let's convert from radical form to exponential form. So now this time we have the radicals and the exponents. And let's go the other way around. Guys, how would you rewrite this first one here, which is the fourth root of c cubed? How would you write that? Yeah, it's just because what becomes the denominator? The fourth root. And then the numerator just stays the one that's being cubed. So when we have that, it's just c raised to the 3/4. Are you guys with me on where those come from? Okay, let's look at the next part with this. It says, convert from radical form to exponential on this one. Who's got this one for me? Caleb, what do you got? Be ready for the next one. All right, so we got b raised to the what? 5/3. Now, if you couldn't remember that perfectly, let me show you another way of thinking about this problem. Knowing that we can rewrite a root as a fraction, could we have rewritten this one as b to the 1/3 power being raised to the what? I'm over here. Pay attention to me. Thank you. Right? Okay. So we have here b to the 1/3 raised to the 5th. Oh wait, can I do the power property? What do we do with our exponents? Get out of my room right now. I'm done. We'll talk in a moment. We don't act like that in my class. Please. Move. I'll come talk to you in just a moment. Thank you. Anyone else want to get in trouble? I'm ready to go. If you're going to act like junior high, you don't need to be in a high school level class. Are you guys with me on that? All right, so can we stay and work on this? All right. So, with this one, my friends, can I use the power property? If you multiply 1/3 times 5, isn't that the same thing as b to the what? 5/3. Now, is it just faster to learn how to convert quickly? Great. Then you need to make sure you do that. Okay, guys, what is going to be our next one? This is where you have to actually probably write a little bit more than a little bit less. How could we rewrite this? What is getting the square root? Is the 5 getting the square root? The 8 is 7 getting the square root? Is it the whole thing? So your very first step better be going to the 1/2. That whole thing underneath that radical is being raised to the 1/2. Okay, so that's when you're working with it. Now, if you choose to do the power property, and you go 5 to the 1/2, a to the 7/2, that's okay. But whatever you do, don't tell me this. Because that's not true. Because the 5 also has to have what? The square root's also happening to the 5. Okay, here's what I want you guys to do. Do the last two problems. I'll be right back. Let's see if we're doing this in the way that makes the most sense, okay? When you're working with this, do you agree what's being used underneath is being raised to the 1/3 power? So the very first thing I would do is I rewrite this, 5x being squared being raised to the what? 1/3. Then, could you do the power property if you want to? Because then you can raise the power, and that becomes 5x. Notice, did that parenthesis go away? No. Raised to the what? 2/3.
So you
Bless
just saw
you.
it work.
So, in this one, I love this one. Let me grab. That one's great. Could you write that in another way?
Could you proceed with proceed?
Yeah, I will in just a second. Yeah. When you have this one, my friends, could I now use the power property on this? You could put this one, and I'm fine with the first one, but isn't it same as 5 to the 2/3 times x to the 2/3? No, power property was basically used twice. But you need to remember, this whole thing is being raised to the 1/3 power. All right. Just out of curiosity, did anyone get it right? That's not too bad. That's not. Some of you did not have parentheses, so let me time out. If you don't have the parentheses, you were wrong.
Well,
It does. You did not have the parentheses, you're wrong. Okay, I'm going to go back for C for mine. Okay, Jack, there it is. Real quick. Okay. With this one, my friends, using that same concept that we just did, what's underneath that radical sign, that cubic root sign, has to go to what? Together. That whole thing is getting the cubic root. So if I'm rewriting this exponentially, what would we write down first? 3x squared. That quantity being raised to the what? 1/3. And if you left it like that, because right now, are we simplifying? No. We're just changing form. Right now, we're just converting forms. We're not simplifying yet. So, if this is the case, you can leave it like that, or what's your other answer I'd be okay with? Well, if I made it look correct, yeah, x to the 2/3. But the key with this one, remember the 3 is getting the cubic root of it as well. Here's what someone's going to do. I'm going to tell you right now. Someone's going to rewrite it and go, oh yeah, that's just 3x to the 2/3. What do they completely forget? They're forgetting the 3's underneath that root as well, correct? You've got to have your what? Make sure. So this one, do this or something to it, because you know you don't want to do that. Parentheses, this is something that's been very difficult for math students for years. I'm telling you right now, students who use parentheses do better than those who don't. So get in the habit of using them. You'll be in a good spot. Are you guys feeling okay with this?
Yes.
Okay, I want to get through in the next 10 minutes. I want to give at least 15 minutes for homework. Can we do that? Yes. Yes.
Do we show that work where it was like the 5x with the parentheses and the square thing?
I think it's worth doing this one.
Or would it be fine if you just want 10x with that?
I mean, this is exponential form, yes, but I would mind if I could. I mean, it's just a good power property thing to do. Okay, now I'm going to ask you to do stuff without a calculator. This homework, the whole homework, and this is a huge integrity thing. Know what? Now calculator. So yes, because if you don't practice that way, when it gets a no calculator section on a quiz, it goes really bad. Okay. So here's the tips that I would probably use for this. Okay. First things first. If your exponent is given as a decimal, change to a what? Fraction. Okay, that makes sense when we have the 2.5, right? Then make sure that you distribute the exponent. You'll see what I mean in a moment, okay? Then you take the root first, power second, okay? Here's why. If you take the root first, the number becomes what? Is smaller. Then it's easier to like square or cube or whatever something. So doing this first. Now technically, should it matter which one you do? No. But if you're trying to do it without a calculator, taking the root first makes the numbers go a lot smaller, so it's easier to do without. Okay? So the example over here, which I really liked because they kept it pretty simple, is right here as an example. First things first, we have 27, x is 6, raised to the 2/3. Guys, didn't we just do the power property? Notice, what did they do to this 27? They took what? Did they take the cubic root? What's the cubic root of 27? Then they had the power. Guys, what's the cubic root of x to the 6? X squared. Now, for most of you, we're going to have to show the cubic root part. But that's the thought process behind this. All right, so let's just do this together. The numbers are not as bad as that example was, because that had a lot of stuff with it. But I think you guys have this down. Should I be able to rewrite this so it's easier to do? All right, so how are we going to rewrite this so that we can, first of all, I don't have any decimals. Okay, so what do I do first? Rewrite it so I have the radical in there. Are you guys with me on that? So what would go inside that parentheses if I rewrite it that way? No, what do we do? The cubic root of what? 8, and that's being raised to the what power? 5. So notice, this is the one that I noted earlier on the other page. I'm like, guys, writing it so you're doing the root first and then raising to the power is easier when you're not having to calculate. Because look what happens. What's the cubic root of 8? Raised to the 5th power. 2 times 2 times 2 times 2 times 2. What do we get? That's not bad numbers. So when you're doing it without a calculator, you want to get it as small as you can. So the root is going to make it smaller. Then we're going to make it larger with our powers that we're raising it with. All right. Let's see if you guys got this one. We have -8 raised to the 4/3 power. What are we going to do first? All right, so the cubic root of -8, and we're going to keep the parentheses and raise it to what? 4th power. Awesome. Cubic root of -8. Now, the -2 to the 4th power. -2 times -2 times -2 times -2 gives you a positive. Remember, if you have parentheses around your negative numbers, if it's an odd exponent, negative answer. Even exponent, what type? Positive. But that's if there's a parenthesis around your negative. And that's one reason why we keep it. Notice, there's lots of parentheses in this. We're not taking the easy route out. Okay, guys, I think you got this next one. Do C on your own. Evaluate it without a calculator. Showing your steps. Some of you already worked ahead, I know. Some of you already worked ahead. Is this making sense? All right, go for it. Let's see how you guys are doing on this. How are we doing?
Oh, you solved it.
Okay. How are we doing? What should you do first? Oh, cubic root first. Then square. All right. So cubic root first. Okay, Nick, make sure you're putting, the numbers are going to work better for you if you do it in the order that I'm telling you. If without a calculator, guys, what's the first thing should I do? Just rewrite it. There's nothing to evaluate. You just rewrite. How do you rewrite this one? All right, so the cubic root of a -64, that whole thing being raised 2nd power. Okay, what's the cubic root of a -64? Parentheses did not go away. -4 now being squared is -4 times a -4, which is a positive. Right on. Use what first? The root first. 5th root, 6th root, 10th root. I don't care. Do the root first when you don't have a calculator. Are you guys with me on this? All right. Now, how about the next one? Where they try to make it look really bad when it's not. Guys, careful. First of all, 1.5 is what fraction? That's 25 to the negative what? 1 1/2 or 3/2. Would you guys agree? Now, 1.5, you're going to get really used for it being as 3/2. But if you need to take the time to convert it first, no one's going to stop you. Now, I did not take the time to convert it first. Do I need to show that step? You guys feel pretty good? Okay. now what should we do? Put that over 1 and do what? Flip. Okay. So then we're going to flip. And we're going to get 1 over 25 to the positive 3/2. Okay, great. Now can we use how to simplify that? How are we going to rewrite that? That becomes 1 over square root of 25, and then we're going to do what? Cubed. All right, guys, you should probably be able to do that in your head, but we're going to go right here. That's 1 over, what's the square root of 25? Cubed. What is 5 cubed? Excellent. You guys do the last one real quick. See what you get. And that's it for homework. I mean, seriously, that is it. That's for Monday's notes.
Oh, cool.
Don't lose these notes. We're going to use them when? On Monday in class. So don't lose them. Which is nice because that means on off-campus room day you're not learning anything new. So that's good.
You're not gonna torture us.
Oh no, you're going to do something, but it's not going to be
I know that, but you weren't gonna torture us.
something new. No video, no note video. Let's put it that way.
What does that mean?
No
Wait,
quizzes
wait.
notes? Stop. That threw me off so bad. The quizzes notes? threw me
Two.
off.
All right, guys, what do we do for this one first? How do we rewrite this?
3 to the
The 5th root of
32.
32,
To the fourth power.
fourth part.
all raised to the 4th power. All right, guys, what's the 5th root of 32?
2.
2 raised to the 4th power.
16.
All right. How are you feeling?
You know what?
Okay, guys, now here's the thing. I want you to do your homework. I have a couple pictures of it, so hopefully I'll put up here at a time. Show work. Do not, this is not, I love you enough to tell you guys, please don't do too much in your head. It will get you in trouble, because that's when you're going to make your silly errors, and I don't want that for you. Okay, so it is textbook work. I have some pictures of this so we can work on there. If you have your textbook, it's always better. But I want your computers flat so I know that you're actually working on what I asked. Sound like a plan?